Well, thank you very much. And we are now ready to start our first session, which is called Forest and Climate Change Risks and Impacts. And I'm now calling our first presenter for the day, who is Hervé Le Bouler. And he's about to talk about the application of the IKS model to all French flora and the consequences of this work on adaptive forestry. Thank you very much.
Thank you for the honor and responsibility to have to start these oral presentations. We are Daisy Copeaux and Hervé Le Bouler, and our subject is Chantilly forest, and more generally, the oak forest of northern and central France. Chantilly forest covers an area of 6,500 hectares. The owners is the Institut de France, who brings together 5 academies, including French Academy and Academy of Science. This forest has a special status. It is a private forest with public management by the French National Forest Office, and it's a pedunculate oak forest. This forest is currently experiencing a serious health crisis. 40% of adult trees are dying or sub-dying. The total of dying volume represents 27 of ordinary harvest. So the main questions are, is that a local, regional or global oak forest crisis? Is that a temporary or permanent crisis? Is that only oak crisis, I mean Quercus robur and Pitre oaks, or a global forest but a biodiversity crisis? And what is the role of climate change, and what is the future evolution?
Okay, the method we use is classical. It's based on ecological niche concept of Hutchinson. This concept say ecological niche are for a species all required conditions to be present and for the species to be able to live and reproduce. It concerns abiotic, biotic, and free access of to landscape conditions. But here we use a simplified approach. This is the Greenellian niche with only 2 abiotic axes, temperature and water balance.
Niche and envelope. Why is it absolutely essential not to confuse them? The niche is a set of conditions necessary for the species to be present. Out of the niche, there is no hope, no salvation, no future. The envelope is a set of observed conditions where the species is present. Out of the envelope, the species currently exists nowhere else on the earth. But no information doesn't mean impossible for the species to be present. The possibility of living for the species must be verified. Anyway, it is then an unknown context. The table below gives the differences between niche and envelope correlated with adaptation.
And here you see in the table, we have information when it is adapted, but we have no information to decide if it is unadapted or if we are still in doubt. And this diagram represents the differences between niche and envelope with the 2 axes, temperature and water balance, in the Greenellian approach. First axis is temperature in vertical, and the second one is water balance. They are the 2 main drivers of response of forests to climate change. The observed presences are blue crosses points. They determine directly the climatic envelope is the green zone. The niche with unknown limits, is in yellow and includes the climatic envelope. Some precisions about the water balance is very classical. It's the annual sum of monthly water balances. Each monthly report integrates the water demand, potential evapotranspiration. Here we use Hargreaves evapotranspiration, and the precipitation and the buffering effect of soil water supply. It's a variable of IKS model. Now we go back to the maps. It's a French maps observed. And in red, 15,000 studied points. There are forest points from IGN where sessile and pedunculate oaks are dominant species. The studied area where Chantilly forest is present, it's a large ecological region defined by the French National Forest Inventory under the name, I'm sorry, it's complicated, Center North, Half Oceanic, Seine and Loire Basin Deciduous Oak Forest. And background colors represent isobioclimates from IKS model. You see in yellow Mediterranean climate, in purple the warm, humid forests. I just come from Bayonne, where this month of November we had just 500 millimeters of water in 20 days. Thank you. And here we go back to Greenellian approach. You see the same colors, the same climate, and you have the position of the stands we studied in red points with climatic envelope, and its Greenellian niche approach. The purple line represents the envelope of all pedunculate and sessile oaks observed in Europe. And the stands we studied in France are clearly in the past climate, before climate change, inside the climatic envelope of the two oak species. It's a sub-dry oceanic climate, and by consequence, we are sure we are in the niche of oaks.
So, what happens when the local climate pops the species out of its climatic envelope? If the species is still in its niche, it is adapted and it remains. But if it is out of the niche, it becomes unadapted and it declines. It's a kind of Spexit. The drought is a risky situation for the forester. The red arrow represents the direction of climate change, and the blue cross in red square, successive positions of forest stands following the future climate. By the way,
On est bon?
ouais, on est bon. These slides show you how studied forests are going out from their known climatic envelope. Indeed, green arrow gives the climate change direction. Red points describes climatic positions of the stands from 1960 to 1990. Brown points are the climatic modelized positions of the stands facing to a warming up of 2 degrees Celsius. Orange points are climatic modelized position of the stands facing to a rising up of 3.5 degrees Celsius. And purple line is the limit of the climatic envelope of the two oaks in Europe. So, what happens when oaks are out of the climatic envelope? Those climates exist in Europe, but we have no known presences of Quercus robur and petrae. We are out of the actual natural range. It's important to note that since 2010, in some forests in France, Chantilly, Compiègne, Fontainebleau, dry stands, growing on a poor maximum stock of water in soils, are already out of these envelopes. So, we know our oaks stands are out of the climatic envelope, but we don't know if they are out of their niche. Out of the niche or in the niche, that is a critical issue for all the foresters to assess the latitude in their management decisions.
Okay, this was about oaks, 2 species, but what about all other biodiversity? Okay. For each stand, we used IGN, local floristic, observed composition with abundance. We studied more than 1,000 species of the regional flora. We distribute them into 4 groups: large tree species, small tree species, shrubs, and all grasses species. For each species, we calculate by the envelope method the limit of tolerance to droughts on European range. And for each stand, each species, and each future climate, the rule was, if modelized drought is out of calculated limit, we take off the species of local abundance. So the result is the percent of original abundance of the groups still inside envelope in a future climate model. We tested 14 future climate models from IPSL and CNRM models. They are French model of GIEC. And here are the maps. The maps represent for the 4 botanical groups in our future climate model, more 3.5 degrees. The colors represent the percentage of original total abundance of species still in climate envelope. From dark green is 90 to 100% of all abundance of all the species of the group still in envelope, to red. Red is less than 10% of total original abundance still in envelope. You must note this. You see, only large trees are really affected by going out of climate envelope. It's probably a good information. But this is about flora. What's about other biodiversity? Animal, fungi, microorganisms, we have no information. And in complement, we give you a slide who illustrates the importance who was revealed by the model of soil-water stock buffering effect on final water balance for group 1, with same stance and different hypotheses of maximal buffer volume of water content in the soil, the impact of remaining abundance is very different. We are here soil from 50 millimeters of equivalent water lamina to 150 millimeters. For example, at 2.5 degrees of climate warming, the remaining abundance is still 100% in deep soil. But when we are in soils with low potential water soak, we are only at 30%. It makes a very big difference.
Concluding remarks for the studied areas, oaks forest in Seine-et-Loire Basin.
First, we have a clear ongoing movement of outing of climate envelope for large tree species.
And this outing is clearly linked and proportional to climate change.
But it has a little impact of rest of plant biodiversity.
But by construction, there is a doubt about outing of the ecological niche. There is probably a real risk of dieback, but it is impossible to quantify.
So we need precise and continuous monitoring.
For a given climate, water balance and subsequent risk of dieback is critically influenced by other environment factors than climate directly. If you protect your soil against degradation, if you bring organic matters, if you limit the direct soil evaporation, and if you use the role of the tree's density and the leaf area index, there can be some impact on your survival.
Okay, this seems wonderful, but always remember this. Who are we, modelers? We are modelers, we are cartographers, we are field of doubt, and we are not cartomancer, we are not Mrs. Irma. Thank you, and special thanks to Tex Avery and this poor but very courageous evil coyote. Something to add, Daisy?
Beep beep.